Good morning, students. It is Devo Miss who is going to take your physics lessons. Before we begin the chapter, let me tell you the question answers of lesson 1 and 2 will be done when we interact with each other after the reopening of the school. Before that, you must study the lesson very thoroughly, both the lesson very thoroughly. You must go through the fact file. You must study the more to know, enrichment and the lesson very thoroughly so that when we do the question answer, we may not face any difficulty. Right? Today, we are going to begin the new lesson, that is turning effect of force. This turning effect of force is mainly concerned with the rotational or twisting effect of force. To explain it very easily, let us consider a door to be opened. When you open the door, what you do first? You hold the handle of the door which is attached to it and push the door to be open. Suppose you have to open a very heavy door. At that time, the force applied by you is not enough. It is the direction in which you are applying the push. And when you apply the force, when you push the door, there should be angle of 90 degree to the plane of the door. That is, it has to be perpendicular. So to explain it more clearly, let's see this demonstration. This is a door which has iron parts at its edge, one edge. These are known as hinge. And let us consider 3 handles of this door. Handle 1, handle 2 and handle 3. If you try to open the door through handle 1, you will find it very difficult to open. Then again, if you try to open it through handle 2, then also you will find it difficult to open. But when you try with handle 1, it is very easy to open. So this handle 1, that means the magnitude of the force applied by you is exactly where it is needed. And the perpendicular distance between the axis of rotation and the line of the force is very well maintained. So from here to this point, this is known as line of action. And this line of action along with the magnitude of the force is known as moment of force. This moment of force can be defined as the magnitude of applied force and the shortest distance between the axis of rotation and the line of action of the force. In other words, it is called torque. So here it is OA is the line of action and A is the point where the force is applied. This is known as torque or moment of force. Since force is measured by Newton and the line of action, that is distance, is measured by meter, force is measured by Newton and distance is measured by meter. So the SI unit of this torque is Newton meter. I hope you all have understood this. So, in other words, torque is a measure of force that can cause an object to rotate about an axis. Hence, torque can be defined as the rotational equivalent of linear force. The point where the object rotates is called axis of rotation. In physics, torque is simply the tendency of force to turn or twist. So the twisting or the turning force which cause motion is called torque. When example of this turning effect in our daily life, let's see. When you unscrew a nut which is fitted to bolt, what you do? You use a spanner with a long arm. As the length of the arm is long, the force required to produce the turning effect is smaller. Suppose in this case we use a spanner whose arm is very short. Then you have the magnitude of the force required is more and it is difficult to open the nut. So it is the line of force and it is the magnitude of the force which affects the turning effect. Next is steering wheels in the car, buses is turned by applying force. By changing the application of force, a steering wheel could be clockwise or anti-clockwise direction. When the steering wheel is in anti-clockwise direction, the force is negative, and when it is in anti-clockwise direction, the force is positive, and when it is in clockwise direction, the turning effect of force is negative. The head of the screw is made wider to produce a larger torque so that the screw moves easily. Same in the case of a seesaw. Suppose there are two children sitting on a seesaw, a heavy child and a lighter child. Now, one side of seesaw will become heavier, and at the center of the seesaw, the point of rotation or the axis of rotation is the fulcrum. So to balance the seesaw, what will happen? The line of force has to be decreased. So here what happens? The heavier boy sits near the fulcrum and the lighter boy sits away from the fulcrum to balance the seesaw so that they can enjoy their playing. Understood? Now, when a force acts on a body, the direction of turning or rotation produced on the body depends on the point of application of the force and the direction applied in which the force is applied. A torque is positive if it tends to rotate the body anti-clockwise, what I have told you just now. It is negative if it tends to rotate the body clockwise. So the positive and negative torque depend upon the rotational movement of the force. If it is anti-clockwise, then the torque is positive. If it is clockwise, then the torque is negative. This is all about today. One more example I would like to tell you. When there is any problem in a car, suppose the tire of the car has to changed. We use a device known as screw jack. You all may have seen. This screw jack is generally kept in the dicky of the car. So this screw jack has a very long handle. This long handle help the force apply so that it gives a large turning effect. If the handle is short, then the magnitude of the force become too high and it is very difficult for the person to change the tire. I hope you all have understood till now. For today, this much. Whatever is left will be taught in the next class. Today's assignment for you is to write the keywords to learn and write all the keywords from page 141. If you have not written the keywords of lesson 1 and 2, please make sure that you write it. So stay safe, stay healthy. Till then, bye.